Hello everyone. Today I'm going to show you how to install Eclipse IDE for STM32 microcontrollers, and also to install the drivers for the stlink programmer and debugger, and installing the OpenOCD debugger. Okay, let's get started. First of all, I will attach this file to my Google Drive, so you can access them easily to review every step you are going to do. Okay, and we're going to install all of these programs on Linux, Ubuntu or Kali, or any distribution that depends on the Debian. Okay, let's install the stlink drivers, and I'm going to upload some of these drivers, stlink and the OpenOCD version, but I'm not going to show how to install Eclipse. It's so easy to find it on the internet, but I'm going to show how to integrate every one of these tools with the IDE. Okay, so we have Eclipse already downloaded and installed. Let's install the stlink drivers. Open the terminal. Okay, and write these instructions. Make install. Okay, now we should find the st flash file located in user local bin. Let's see. Yeah, it's already located in this directory. Okay, now we are done with the stlink driver. Actually, you will find some errors with other versions, but I will upload this version so you can easily follow the steps that we are doing. Okay, but the latest version of the stlink drivers have some problems, and I'm not going to experience these problems. Okay, so I will upload this file on my Google Drive. Okay, now let's turn to the OpenOCD. OpenOCD is some kind of debugger. It's an on-chip debugger. Okay, you will find it on my drive like this. You can enter it to get this folder. Copy this folder to /opt right here. Okay, and we are going to do the following. We have the instructions, so you can review everything you are doing. Okay, we already done this. We already have done this. We need to configure, make install. So we can configure. Make. Everything's fine. Okay, make. and finally make install. Everything is okay. It's very important to find the OpenOCD configuration file located in the same place that we have found the ST flash in it. Okay, so we have to check it. OpenOCD. Let's already use the local pin again. Okay, so now we are done with these things. Let's turn to the next part. We've done this and this. The ARM toolchain should be only downloaded and installed. This is a portable version of the ARM toolchain. So I untap this to home and create a directory called OPT and put it here. Okay. Now we configure the three things. Open Eclipse, and also in the instructions we'll find everything here. To integrate the OpenOCD with Eclipse, open run configurations or external tools. Under the program tab, we can hit double click to open a new configuration or new to do the same thing. Actually, I've already done everything, but I'm going to review it with you. First of all, we are going to create a configuration for the stlink flasher, which is responsible for converting the code to your microcontroller STM32. In the location, we already have this, and we validate it. And the next thing is to choose the release folder in your project location, which has the hex file or the binary file, all of them. And this is the instruction to write your code to the microcontroller. Okay, everything else is has nothing to do with us. We don't have to change anything else. We can run, but I'm not going to run now. Also, we have to configure the OpenOCD debugger, the same location, but the OpenOCD configuration file. We have no working directory, but we have here an option or argument. We have to open this, and this is the most important thing in this tutorial, because actually I was stuck for 6 or 7 days for finding such file for solving my problem. Okay, so we have to copy this file to this directory. Okay, and I will post it also. You can find this file uploaded with the OpenOCD file folder. Copy, go here and go to TCL board and paste it. I already have it. Okay, so I don't have to put it again. After doing this, you have to put the whole directory or path and -F for finding such file when you are opening the debugger. Everything else also is okay. I can run, but let's continue. Open, run, then debug configuration. Under the GDB hardware debugging, we have to double click to create a new configuration. We can call it anything, debugger for example. Okay, and the project can be the project name for general, or can be your project. Okay, so we can write it Okay, we can write it like this for a generic use, or we can write it your project. Once you create your project, you can have this option. Okay, the application is the .elf file. You can search and you can find it. Once you debug your code, you can find the .elf file produced, and you can choose it. Okay, we don't have to play with these things. Okay, but this is the most important thing, is to choose the debugger. Okay, here we have the tool chain. I untarred it, and as I said, you have to put it in this folder /home or home and OPT, different OPT from the main OPT of the system. No, it's a new OPT folder. Okay, under home, and this is the latest version of the tool chain. And here are the binaries. You have to choose this location like this and paste it here, the GDB command. Okay, this is the place where I'm locating my GDB. Okay, you can browse also and choose your debugger. Okay, change it to generic TCP/IP and change this to 4 threes and like this, and apply. Okay, let's test it. Connect your STM32 microcontroller. I'm working on STM32 F103 CAT6 microcontroller chip. So let's test it. I already created a project and I can debug it and release it. Okay, source, the main file. Okay, let's try to run the external tools. A flasher. Okay, I have no problem actually, but when you are writing your code for the first time, you will have a problem. Okay, so we're going to mention how to solve it. Go to project after choosing your project. Okay, and open properties. Okay, C++ build and choose settings and wait. Okay, you have to choose here all configurations. Okay, to apply this option for all configurations, and scroll down until you find the cross-arm no create flash image and go to general, and also you have to convert it to raw binary instead of Intel hex. This is the default option, but we need a raw binary. Okay, hit OK, and now we can open the OpenOCD debugger. Okay, it should look like this. Otherwise, if you see something like this, target needs reset or drop GDB debugger or things like that, it's probably the problem of the configuration file that we talked about. We talked about that the configuration file is a very important thing for the STM32 F103 C86. This file. Without this file, I think you will probably experience a lot of these errors. So that this is actually the error that I had. So this file solved my problem. I think this is the line that I couldn't find. Okay, so now everything is okay for me. Okay, now the debugger is working. The on-chip debugger is working. Now we can open a session for the debugging. Okay. Now the debugger is connected. Okay. Now we can debug everything inside the microcontroller. And in next video, I'm going to show how to install the plugin that is capable of showing the embedded registers, such as the GPIO registers and other registers. Okay. If you have any problem, you can comment on this video, or you can send me a message so I can help with this. Thank you, and see you in the next tutorial.